Welcome to This Explainer. We're diving straight into a really fascinating puzzle today. How exactly do we adapt renewable energy for tight, incredibly complex city environments? It's an absolutely crucial challenge for our future, so we're going to get right into it.
You know, when you picture solar panels, you probably imagine massive, endless arrays stretching out across wide open fields or baking in the desert sun. But what about our cities? Urban areas currently consume around 75% of global energy, yet historically they generate almost zero of it locally. There's this common myth out there that urban buildings are just too constrained, too crowded, or too awkwardly shaped to generate their own power. Well, today we're going to completely challenge that preconception.
Here is our agenda for today. We're covering 1. The Urban Solar Challenge. 2. Seamless roof coverings. 3. Ballasted systems for flat roofs. 4. Multi-purpose solar canopies. 5. Transparent decorative solar panels. And 6. Finding your perfect fit.
Starting with Section 1, the Urban Solar Challenge, demystifying city installations. Look, generating energy in a city is notoriously difficult. We're dealing with a severe lack of space, totally unpredictable shading from skyscrapers, and an incredibly tricky variety of roof types. Standard solar panels just don't work everywhere. We need highly specialized tools.
Moving to Section 2, Seamless Roof Coverings, Building Integrated Photovoltaics. We are going to begin our structural tour right at the very top of the urban home. With pitched roofs,
Notice how incredibly flush and natural the active solar panels look here. In the background, those dark panels are actually integrated directly against the pitched roof structure itself. They literally form the waterproof surface. Contrast that with the traditional unmounted blue panel just resting on the ground in the foreground. The integrated version doesn't hover above the roof on bulky metal racks, it literally becomes the roof.
This specific technology is known as BIPV, or Building Integrated Photovoltaics. It seamlessly replaces traditional roofing materials. And this matters immensely because it proves that adding solar to an urban home doesn't have to look clunky or feel like a bolted-on afterthought. You don't have to sacrifice the architectural beauty of a residential neighborhood just to generate clean energy. By maintaining that premium aesthetic, these installations can actually increase property value while simultaneously pumping out sustainable energy.
Next up, Section 3, Ballasted Systems for Flat Roofs, Engineering Without Penetration. Moving along on our tour, we arrive at arguably the most common commercial urban structure, the flat roof.
This brilliantly illustrates the practical engineering required for flat urban spaces. Notice the heavy concrete blocks acting as the foundation for the metal mounting frames? The panels are angled perfectly to catch the sun, but instead of being screwed into the roof itself, the entire structure is just weighed down by those thick concrete blocks positioned right at the base of the metal legs. We call this a concrete ballasted system. It's a mounting method that relies entirely on heavy weights to secure solar arrays. So why is this so vital for cities? Because penetrating a flat urban roof with lag bolts is a guaranteed recipe for water leaks and structural damage over time. Instead, gravity does all the heavy lifting, and it really has to be heavy. Urban wind updrafts bouncing off skyscrapers can act like a parachute against solar panels, so these ballasts have to weigh hundreds of pounds to safely preserve the building's waterproof membrane.
All right, Section 4, Multi-Purpose Solar Canopies, Maximizing Usable Space. Let's see how we build an urban energy profile when we actually need to use the outdoor space for ourselves.
Imagine just standing underneath this elevated metal frame. You're on a highly usable, fenced-in terrace, which, let's be honest, is an absolute premium commodity in any city. But instead of just empty sky above you, the roof structure is a canopy of active solar panels. The robust steel framing lifts the energy generation high above the floor, completely freeing up the ground level for human activity.
This brings us to the dual utility of solar canopies. First, it generates renewable energy. Second, it provides much-needed structural shade in hot, concrete-heavy urban environments. And third, it meticulously maintains the usable square footage below. It transforms an otherwise exposed single-use patio or rooftop parking area into a dual-utility asset. When urban real estate is valued by the square inch, overlapping our energy infrastructure with our living spaces is absolutely critical.
Let's look at Section 5, Transparent Decorative Solar Panels, where design meets function. For our final structural stop, we're looking at something truly special, blending high-tech energy generation with high-end aesthetics.
Look up through this structure. It genuinely inspires a bit of awe to see how these transparent panels blur the line between basic building materials and energy generators. You can clearly see the blue sky and clouds right through the glass, while the dark, grid-like photovoltaic cells are embedded directly inside it.
It acts as a beautiful, modern architectural canopy while silently harvesting the sun's power.
Comparing this directly, traditional opaque panels block all light, right? They're strictly functional, and architects usually try to hide them from street view. Transparent solar, on the other hand, allows natural light to filter right through. It's highly aesthetically pleasing and can be actively used for skylights, glass facades, or decorative awnings. The crucial point here is that solar technology has evolved to the point where it can actually be the architectural centerpiece of a building, rather than just utility equipment you hide on the roof.
Finally, Section 6, Finding Your Perfect Fit, the Solar Menu. Having toured all these diverse possibilities, it's incredibly clear that going solar in the city is definitely not a one-size-fits-all approach.
Looking at this typology guide, you can see how perfectly these solutions map to specific urban problems. If you have a pitched roof and care about neighborhood aesthetics, BIPV roof coverings are your answer. Have a flat commercial roof and absolutely cannot drill into it? Concrete ballasted systems are the way to go. Desperate for usable outdoor space? Elevated solar canopies let you have your cake and eat it too. And if you're designing skylights or glass facades, transparent decorative panels offer a stunning, functional solution. No matter your specific urban constraint, there's a specialized tool engineered precisely for the job.
Armed with this knowledge, you can begin to look at your own urban spaces entirely differently. Every flat roof, every sun-drenched patio, and every glass awning represents a totally untapped opportunity. So, I'll leave you with this final thought. When you look out your window today, which of these solar solutions do you see powering the future of your city's skyline? Thank you for exploring this with me. Keep learning and keep looking up.